This is section 3.3, part 2, rates of change and behavior of graphs. We're going to begin talking about how to describe where a function increases, decreases, and is constant. And what we do is we give that interval in interval notation, okay? And that interval will identify where f increases, decreases, or is constant, okay? Now, this explanation may be a little bit, maybe too detailed, but I just want to show you something. This is where f increases. So let's just say we have a function and it's increasing, and we have x1 and we have x2. All this is saying is if x1 is a smaller number than x2, which is what we've done here, the y value for x1 is lower or less than the y value for x2. That's how you know you have an increasing function. Likewise, let's take care of this, the same graph, but now they're saying that x1 and x2 y values, now x1 is still less than x2, but now the y value for x2 is greater than the y value for x2. So that y value for x1 is greater than the y value for x2. And let's look at this last case, constant. So if you have a constant function like that, and you have x1 and you have x2, they're just saying that the y values are the same. So that's how you know you have a constant function. Let's give this a try. In example 6, the figure shows the graph of a function. Determine the intervals over which the function is increasing, decreasing, or constant. So what I like to do is I like to go ahead and write these down. Increasing, decreasing, and constant. And then I move from left to right. So I'm going to work on this piece right here. And as you can see, the y values are getting smaller as you move from left to right. So we are definitely decreasing. And we are decreasing from negative infinity all the way here to -2, it looks like. And that's open, okay? Now, let's go to the next piece of the graph. As you can see, this graph is constant here. So we are constant from -2 to 2. This is a half open, half closed interval. Okay? Now, let's go to the third part of this graph. And I just moved from left to right. You don't have to do that. And as you can see, our y values are getting larger, moving from left to right. So we are increasing. It looks like that starts at 2 and goes all the way to infinity. Okay, let's look at example 7. The figure shows the graph of a function. Determine the intervals over which the function is increasing, decreasing, or constant. So I'm going to go ahead and just write these and get ready. And I'm going to move from left to right. So from left to right, I see that my function is decreasing here. My y values are getting smaller. Let's see, -1, 2, 3, 4. I better put a -5 there. 1, 2, 3, 4. I'm going to put a 5 there. That will kind of help me. So it looks like we're decreasing from negative infinity all the way to -5. You can use an open or a closed. When they're connected, you can use either. I'm just going to keep it closed. Okay, let's go to our next piece. It's right here. And we are definitely have our y values increasing. So I'm going to go from -5 all the way, that looks like a -3 there, to -3. Now we have a part of the graph that is constant. So that is from -3 to -1. Okay, let's look at this next part. The y values here are getting larger. Okay, so that's from -1 to +1, increasing. So I'm just going to use a comma here and just put -1 to 1. Okay, let's look at this left part, and it is all of that because the y values here are always decreasing. So that is from 1 to 4. Now we have another piece, increasing, and that looks like it's just from 4 to 5. So I'm going to put a comma, 4 to 5. And we didn't have as many in that problem. And this last part, yep, you guessed it, constant. So we're constant, the function is constant from 5 to +infinity. Okay, let's go to example 8. So we're practicing writing intervals of increase, decrease, and constant. Now note that they just want intervals of increasing. So I'm just going to write increasing, and that will remind me that's all I have to do. So I'm going to go ahead and make some points where we change over from increasing to decreasing. And that way I just get ready. So I'm decreasing here, so I'm not going to write anything, but I am increasing here. Decreasing there, but increasing there. So let's write those intervals. We're increasing from 1 to 3 and from 4 to infinity. Okay, 4 to infinity and from 1 to 3. That's what we're describing. We're using x values. We use intervals of x to describe behavior of y values. So where are these y values increasing? Where are they decreasing? So I really like this explanation. We use intervals of x to express or to describe where and what our y values are doing. Okay, let's look at this example. Given this function p of t below, identify where the function appears to be decreasing. I'm going to put just the little changeover points there, and you can see we are decreasing here and decreasing here. So intervals where the function is decreasing is -infinity all the way to -1, and then from a +1 to infinity. And the last example is the relationship between the number of gallons, G of t, so this is gallons of water, in a swimming pool, and this is over time. So when we start out here, we have, so at t equal to 0, there are 0 gallons of water in the pool. So the pool is actually empty, and we start filling the water. Over what period of time is the water level changing most rapidly? That means the greatest slope, and that could be either positive or negative slope. But we notice that the greatest slope is positive. So that is increasing there. There is a slope, changing slope, but it's not as great. It's not as negatively great as this is positive. So this would be on the interval from 0 to 25. So time 0 to 25. After how many hours does the water level start to decrease? So here it's increasing, it's staying constant here. It's not until this time, which looks like 50. So at t equal to 50 hours, or after 50 hours. And then last is how many gallons of water are in the pool after 75 hours. So at 75 hours, there are 2,000 gallons of water in the pool. And that concludes this last part of section 3.3.